You lie still beneath the hush of night, and as the world softens into darkness, you drift inward, past the surface of your skin, down through layers of living tissue, until you arrive at the smallest theater of life, the cell. It is here, in the soft glow of your imagination, that we first find the script that built you, not in paper and ink, but in a spiral staircase of light and shadow, your DNA. These twisting strands are wound tightly, like a lullaby whispered through generations, coiled safely inside a nucleus no wider than a dust mote. And yet, this is where your story begins. Each strand of DNA is made of four simple letters: A, T, C, and G. They are not letters like those on a page, but molecules, dancing pairs that cling together like old friends. A with T, C with G. This alphabet does not spell words, but instructions, songs, recipes, blueprints. Every blink of your eye, every breath you take, every beat of your heart is quietly guided by these codes. Your DNA is nearly 2 meters long, but it folds itself expertly into each microscopic cell. If unwound from every cell in your body and laid end to end, it would stretch the moon and back hundreds of thousands of times. And yet, it remains hidden silent, tirelessly at work. As you listen, imagine standing within a single cell, surrounded by warm, gentle hums. Around you, molecules float like lanterns in a dark sea. Inside the nucleus, enzymes move like careful hands over the spiral staircase of your DNA, reading and copying it so its instructions can be carried out. One of the first things DNA does is tell the cell how to build proteins, the builders, messengers, and tools of life. Some proteins give your blood its color. Some repair broken pieces of tissue. Some decide the color of your eyes or the curl of your hair. Others remember infections, helping your immune system learn how to protect you. But DNA is more than a manual. It is a history, a memory, a letter from every ancestor who lived before you. Inside your cells are fragments of stories written by ancient fish who first crawled onto land, by mammals who grew fur against the cold, by humans who survived storms and sickness and silence. And not all of these stories are perfect. Along the long road of time, tiny changes have crept into the code, mutations. Some are small mistakes, like a single letter swapped out. Others are like pages shuffled around. Many do nothing. A few cause illness, but some, strangely, lead to strength, to evolution, to change. You, lying still tonight, carry both the errors and the brilliance of your genetic past. The freckles on your skin, the tilt of your nose, the rhythm of your heartbeat. They are echoes of choices made by cells long ago. DNA is a storyteller, but also a puzzle shaped by need and chance and survival. Now imagine this. When a cell wants to use a part of the DNA, it opens a spiral just a little, like lifting a corner of a sleeping blanket. It reads the letters and creates a message, an RNA strand, a messenger that floats out of the nucleus and into the wider city of the cell. There, in tiny ribosomes, the message is translated into action. The RNA is read 3 letters at a time, codons, and each trio calls forth a specific amino acid. Like beads on a thread, these acids line up into a chain, and as the chain folds, it becomes protein, a tiny machine, a piece of you. All of this delicate ballet, happens every second, silently, within every one of your cells. You don't feel it, you don't hear it, but it never stops. You are being written over and over like a poem with a pulse. Even as you sleep, your cells are alive with quiet urgency. Bones are being repaired. Skin cells are dividing. Memories are being shaped. Hormones whisper their instructions, all guided by the same ancient code. DNA is remarkably stable. It can last thousands of years under the right conditions. That's how we read the genes of Neanderthals and mammoths. But it is also fragile. A single burst of sunlight or a stray molecule can damage it. That's why cells have repair crews, enzymes that scan for breaks or mistakes and mend them with care. But even with these repairs, change still finds a way. That's how life evolves. The slow, winding drift of genetic change, generation after generation, leads to wings, lungs, eyes, dreams. And so, In every human, in every living thing, DNA holds a memory of survival. You are a product of that survival. Your DNA shares more than 98% similarity with chimpanzees, over 60% with a banana. This isn't just a curiosity, it's a sign that all life is connected by the same language, spoken differently in each body. And yet, your DNA is uniquely yours, like a fingerprint of your very being, from the swirls in your irises to the way your brain responds to music. These are shaped by your genes, but not your genes alone, because your environment, your choices, your thoughts, they also shape how your DNA is used. Some genes are turned on like lights in a room, others dimmed or silenced. This is called epigenetics, the study of how life's experiences write notes in the margins of your genetic book. Imagine it this way. Your DNA is a song, but the way it's sung can change. A cello or a piano, fast or slow, loud or soft. The notes are there, but the melody shifts depending on the world around you. And now, think of how this story began. Long ago, the first strands of self-copying molecules floated in a warm, ancient sea. They were simple, crude, but they carried something powerful, the ability to remember and repeat. Over time, those strands became more complex. They learned to protect themselves, to build, to pass their information forward. And now here you are, a galaxy of cells, each one humming with that old song, each one bearing the story that began before time had names. You are not separate from nature. You are one of its finest instruments. You may never feel a single protein fold. You may never see a strand of your DNA, but it sees you. It remembers you. It is you. And as you rest tonight, your cells continue their quiet rhythm, carrying the story onward. In the next chapter, we will follow that story as it begins to move, not just within you, but between you and the world. We'll journey into breath between cells, the delicate bridges where signals leap, and ask, how do your cells speak? What language do they share in silence? And what secret messages flow through the space between them? You rest now, gently cradled by the quiet of night. But deep within your cells, the story continues. A soft script still unfurls, written in the spirals of DNA. A record of life's long journey, passed down from parent to child, body to body, error to error. Some of these errors are harmless, like a forgotten comma. Others are more painful, mutations that lead to illness, to suffering, to silence. For centuries, the code remained untouched. Scientists could read it, yes, they could observe the letters, but the story could not be changed. Not truly. The words were locked in place, sacred and untouchable, until recently. In a calm and focused laboratory, not unlike a whispering library, an editor quietly arrived, not one with a red pen or a loud voice, but one made of protein and precision. CRISPR. CRISPR is not a machine, not a robot, not even alive in the way you are. It is a molecule, just a tool. But like a chisel in the hands of a sculptor or a needle in the hands of a healer, it holds the power to change. And it all began with bacteria. Long ago, scientists noticed something strange in bacterial DNA, short, repeated sequences. Between them were fragments of viruses, like mugshots filed away after battle. This was CRISPR, an ancient immune system. When viruses attacked, the bacteria saved tiny pieces of their invaders' DNA, storing them like memories. If the same virus returned, CRISPR would recognize it, and with the help of a protein called Cas9, it would cut the virus apart. This natural defense became a key. What if scientists wondered we could use this mechanism, not just to fight viruses, but to edit DNA, to remove a faulty gene or fix a broken one, to acquire a mutation that causes disease, or add a helpful instruction. And so, with the care of poets and the caution of physicians, they began to teach CRISPR a new song. Now, when scientists use CRISPR, they send in a small guide, a piece of RNA, shaped to match a specific part of DNA. It floats quietly into the cell, searching for its match in the genome. When it finds it, the Cas9 protein moves close. It's a pair of molecular scissors, guided by the RNA's touch. Cas9 makes a precise cut in the DNA, snipping it like thread. But cutting is only the beginning. What comes next is healing. The cell notices the break and rushes to fix it. Sometimes it seals a gap quickly, disabling a troublesome gene. Other times, scientists provide a new piece of DNA, like a patch for a torn garment. The cell stitches this new message in, rewriting the story just slightly but with great meaning. You can think of CRISPR like editing a single letter in a novel. One tiny change in one word can shift the meaning of an entire sentence. A single mutation, say, replacing an A with AT, can mean the difference between health and disease. But if that letter is changed back, quietly and carefully, the original meaning returns. This is no longer fiction. Already, CRISPR has been used to correct genes responsible for blindness, to treat blood disorders like sickle cell anemia, to study cancer, HIV, and even aging. And it's still learning, still becoming. But this power raises questions, doesn't it? If we can edit the story, where we draw the line. Should we rewrite only what's broken, or should we chase perfection? You might wonder, lying here tonight, how far this tool could reach. Could it mend the pain written into your family's genes? Could it erase a child's suffering before they're even born? Could it end diseases we've long called incurable? And if it can, should it? CRISPR offers promise, yes, but it also asks us to think deeply, because when we edit DNA, we're not just altering molecules, we're shaping lives, shaping futures. The smallest cut in the code may ripple outward, through generations yet to come. Imagine standing at the edge of a vast field. In your hand is a single seed. With CRISPR, you can change something in that seed, a single trait. But what grows from it, what blossoms, what spreads into the next field and the next, is not always predictable. And yet, in careful hands, CRISPR can be gentle. It can restore sight. It can silence a mutation that causes pain. It can be an act of kindness, written at the molecular level. But like any powerful tool, it must be wielded with care, with consent, with humility. It is not magic. It does not rewrite the past. But it may offer hope for the future, a quiet way to say, you don't have to carry this burden anymore. Tonight, as your breath slows and your body rests, imagine that within you, a scientist of light and kindness is moving gently through your cells, reading the code with compassion, searching for places that can be softened, healed, or rewritten with love. CRISPR doesn't create life. It doesn't design new species from scratch. It listens. It watches. It edits delicately. You may never feel it. You may never see it. But the possibility now exists that stories written in pain can be revised in peace. Of course, not every edit is clean. Sometimes the cut is too wide, or the repair imperfect. Cells are complicated. After all, full of feedback and noise. Like trying to tune a violin in a thunderstorm. But we learn, we refine, we return again and again to the code with better questions and steadier hands. You are the bridge between what was once unchangeable and what may someday be healed. And as you lie here tonight, you carry that possibility in every cell. That suffering inherited may not need to be passed on. CRISPR whispers a new kind of lullaby, one of precision, promise, and patience. It reminds us that while our stories begin with inheritance, they don't have to end in inevitability. And so, under the watchful eye of night, the editor begins his work. Quiet, gentle, hopeful. But before we can understand what CRISPR can heal, we must understand what it means to be broken. In the next chapter, we'll follow a single mutation, one small change in the code, and trace how it echoes through the body. What happens when a single misplaced letter reshapes a life? You lie in stillness, breathing gently, as the world softens into a hush. And somewhere deep inside your imagination you travel, not upward into galaxies, but downward into the unseen, past skin and blood, beneath your bones, into a world far smaller than a single cell. Here, in the darkness of a drop of water, in the quiet of a forgotten tide pool, something extraordinary is happening. A virus enters a bacterium, uninvited. It carries only one purpose: to hijack, to multiply, to take. It is ruthless, efficient, but the bacterium is not defenseless. Long ago, nature gave these tiny beings a secret weapon, one that does not strike first, but remembers. This is where CRISPR was born, not as a tool of precision in a glass lab, but as a humble memory system tucked within simple life. CRISPR is not one thing, but a pattern, a way to archive small fragments of DNA from viruses that attacked before. If the same virus returns, the bacterium recognizes it, and then it fights back. This memory is not stored in the brain. Bacteria have no minds, no thoughts, no dreams. But they carry remembrance in a more ancient way, through sequences etched into their own DNA. Like a notebook passed through generations, each viral fragment is cataloged, separated by repeating patterns like careful punctuation marks. These repeats are what gave CRISPR its name, clustered regularly interspaced short palindromic repeats. A mouthful for something so quiet, so powerful. And beside the CRISPR sequences live the Cas genes, blueprint for proteins that act as sentinels. Cas9, the most famous of them, is like a microscopic blade guided by memory. When a bacterium is threatened by a virus it has seen before, it creates a piece of RNA, a guide, matching the viral DNA. This guide RNA holds a memory, the recognition. It finds a threat. Then Cas9 cuts it apart. Precise, clean, without noise. It's a dance of defense written not in fear, but in survival. You imagine it now, this microscopic theater. A virus floats in, unfamiliar and bold, but the bacterium has seen its shape before. The memory is awakened. The RNA guide is written. Cas9 joins, blade in hand. The threat is neutralized silently, with no grand finale. Only peace returning to the cell. And for centuries, this war played out unseen, unnoticed, until one day, human eyes observed a strange pattern in bacterial DNA. And they asked, why would a bacterium store viral code? With curiosity and patience, scientists decoded the language. And in this ancient offense, they saw a mirror, a way we, too, might remember and edit. Now, you carry this ancient wisdom forward, not in your own DNA, but in the knowledge your species has gathered. What began as a microbial whisper has become a conversation with the future. CRISPR, born from the struggle between life and invasion, now gives us power over the very code of our bodies. It teaches us that even the smallest life holds answers, that the universe hides its keys not only in stars and oceans, but in single cells and silent bacteria floating in sunlight. And it shows us that memory is more than thought. It is structure, molecule, repetition. It is the shape of experience preserved in a physical form. As you rest, you are part of this long lineage of learning. The knowledge of CRISPR doesn't only belong to labs or libraries. It belongs to you, too, because it changes how you understand your body, your story, your future. Imagine being able to recognize not only what harms you, but to gently rewrite it, to take the harmful memory out of the spiral, to leave behind a cleaner strand, a clearer path. That is what bacteria learn to do, and that is what we now aspire to remember what once hurt us, so we may no longer be hurt in the same way. But this is not only about healing. CRISPR opens a new door, a door into possibility. The more we learn, the more we must ask, what will we remember? What will we choose to forget? And how will we carry these choices forward from one generation to the next? Tonight, you drift beside these questions, not answer them, but to hold them gently. To understand that every great discovery is a beginning, and every small life, like a bacterium, is a teacher. CRISPR is a reminder that protection can be silent, that memory can be molecular, that wisdom can come from the most unexpected corners of existence. And as you drift deeper into rest, let this thought settle around you like a soft blanket. You're made not only of cells and stories, but shared secrets passed down from life to life. The defense of bacteria, the guidance of CRISPR, the hope of healing, all live in your time now. What they whisper to survive, we now speak to understand. In the next chapter, we will follow one of those whispers all the way through the human body. We'll explore how a single mutation, one tiny change in code, can shape everything from blood to breath. What happens when a single letter out of place becomes a lifelong sentence? The night deepens, and so does your breath. Your body rests, yet within, the quiet story continues, unfolding like pages in a book too old to remember its beginning. You are made of chapters written long before your first cry, long before your heart beat its first rhythm. And among those ancient letters, tucked deep in the spiral of your DNA, live both gifts and shadows. These shadows are not born of your choices. They are old echoes, mistakes in the code passed gently from one generation to the next. A single wrong letter, a misplaced switch, a silence where a sound should be. These are the whispers of inherited disease. Imagine your DNA as a garden grown in twilight. Most of its flowers bloom bright and strong, coding for health, resilience, the ordinary miracles of the body. But here and there, among the petals, a weed appears. Sometimes it grows slowly, barely noticeable. Other times, it spreads quickly, overtaking the beauty, choking the light. These weeds might be a blood disorder, like sickle cell anemia, where one single change in a single gene causes red blood cells to curve and stiffen, becoming moons instead of discs. Or cystic fibrosis, where a missing segment leads to mucus that clogs and suffocates. Or Tay-Sachs disease or Huntington's or muscular dystrophy. Each begins with one small error, one letter off, one misfolded truth. And yet, you do not curse the garden for its weeds, because within the same spiral that carries pain, there is also the map to healing. The question becomes, how we tend to this garden gently, without tearing its roots? This is where CRISPR returns, not with loud tools or violent force, but with careful fingers and a surgeon's grace. CRISPR sees the weed and does not destroy the garden. It clips only what must be clipped. It listens to the blueprint and corrects it, not to erase history, but to soften its burden. Let's return to sickle cell for a moment, a disease caused by one letter change in the gene that makes hemoglobin, the protein in your blood that carries oxygen. One tiny T swap for an A, one small typo that makes cells brittle and twisted. But with CRISPR, that single letter can be carefully replaced, the correct letter restored, and with it, the shape of the cell, the breath, the life. It's like finding an old lullaby passed down for centuries and discovering one wrong note, one sharp instead of soft, and then slowly, lovingly rewriting that one note so the whole melody can finally play in peace. But even with such promise, the process is delicate. First, the cells must be found, the ones that hold the faulty code. Then, the CRISPR system is introduced, the guide RNA, shaped to seek the broken segment, and Cas9, the scissors ready to cut. Once the faulty gene is snipped, the cell's own repair system is activated, and with help, the correct sequence is patched in. All of this happens invisibly. No grand announcement, no spotlight, just the quiet precision of healing at its smallest scale. You may wonder what it feels like to have your DNA edited, but most never feel it. There's no ache, no scar, only the slow, unfolding result. Fewer symptoms, less pain, a different path. Sometimes the CRISPR edit is done in the body itself, in vivo, as scientists call it. Other times, cells are taken out, edited in the lab, then returned, like gardeners pruning a branch before replanting it in richer soil. Still, it's not perfect. There are off-target effects, times when the scissors cut the wrong part. There are challenges in delivery, how to get CRISPR into the right cells safely, in time. And there are questions, deep and ethical, about when and where we should use this power. But tonight is not for debating ethics. Tonight is for marveling at the gentle hands of science, reaching into the spiral of fate and offering a different ending for those born with pain written into their code. CRISPR whispers a softer story. You are not your mutation. You are not bound to suffer. There is hope, even in the smallest molecule. And the beauty of CRISPR lies not just in its strength, but in its specificity. It does not overwrite. It does not scorch the page. It finds a single word, a single flaw, and rewrites it with care, like a poet revising a painful stanza until it sings again. And in this, it honors what came before. It doesn't deny the past. It simply asks, what if we could carry forward only what heals? Imagine parents carrying genes that once guaranteed disease. And now, imagining a future where their child's body is not shaped by that same fate. That future, once myth, now approaches slowly, deliberately, on the quiet footsteps of CRISPR. But as the garden heals, a new question rises like mist over the soil. Where do we stop? If we can snip away disease, should we also remove discomfort? Should we add it for strength or beauty or brilliance? The line between healing and enhancement begins to blur. The garden we tend may bloom too far, growing vines where walls once stood. And so, CRISPR's promise comes with a quiet invitation, not only to act but to reflect. What does it mean to be human? To be imperfect? To carry both shadows and light in our spiral script? As you lie here tonight, these questions rest beside you like warm stones. You do not need to answer them, only to hold them, like petals between your fingers, wondering at their softness. CRISPR, standing in the moonlit garden, does not rush. It watches, it listens, it clips gently, and in doing so, reminds us that healing is not erasure, it is transformation. So breathe now, knowing that within you and beyond you, science walks softly toward the wounds long thought untouchable, that the spiral of life, once rigid, now bends slowly, carefully, toward possibility. And as the shadows begin to recede, the stars above your resting body seem to lean in, curious, because what we snip in the spiral of DNA may echo far beyond the cell. In the next chapter, we'll leave the garden and enter the question that stirs just beyond it. If we can shape life itself, how do we choose who decides? You lie still, wrapped in the quiet hush of night. Somewhere far from your room, in a softly lit lab, someone else is awake, not with urgency, but with reverence. They lean gently over a microscope, hands still, mind open. And in that space, filled with hums and silence, the soft debate begins. It is not loud. There are no raised voices or slamming doors, just whispers of questions that do not go away. Questions that press against the glass of progress, asking why and how far. CRISPR has given us the ability to touch the spiral of life, to cut it, to rewrite it, to heal what was once thought untouchable. But as with any tool of power, there comes a moment when the hands that hold it must pause. This is that moment. Picture a long table beneath low light. Scientists from many lands gathered not with answers, but with care. Not all wear white coats. Some carry books of law, others hearts heavy with history. All are here to listen, to wonder, to hold the candle of ethics steady, while the winds of discovery blow. The questions drift gently across the table, slow and steady. What does it mean to edit a life before it begins? Who gets to decide what should be changed? And when we cut away suffering, are we also cutting something essential, something we don't yet understand? You imagine the scientists now, sipping tea gone cold, their eyes soft with the weight of the possible. Because it is not hard to imagine using CRISPR to erase a devastating disease. But what about sadness, or memory, or the ordinary quirks that make someone different? Where's the line between healing and redesign? Imagine a future parent holding the promise of a perfect child in their hands, a child without genetic disease. Yes, but also taller, perhaps smarter, more beautiful by someone's definition. A child sculpted from preference, not just protection. Is that still medicine? Or have we slipped into a quiet kind of manufacturing? The lab grows quieter still. Ethics is not a wall. It is a mirror. And in that mirror, each of us see something different. Some see hope, others caution, many both. It is here in this gray space that the candle of ethics flickers most gently, because there are no simple rules, no absolute paths, only choices, each one a brushstroke on the future. CRISPR can be used to save a life, yes, but it can also deepen inequality. If only the wealthy can afford its gifts, it can help a family, but change the course of evolution. It can prevent pain, but also erase the diversity that shapes humanity's strength. So the questions must be asked again and again. Who benefits? Who is left behind? What are we preserving? And what might we lose? These questions are not enemies of progress. They are its companions, like stones lining a river, guiding its current so it doesn't flood the valley. And even in the softest science, there is still history. History remembers experiments done without consent, communities hurt in the name of knowledge, people labeled as less simply for being different. The memory of these wounds rises quietly in every conversation about CRISPR, and rightly so, because the hands that hold the future must also carry the past. And yet, we do not stop walking forward. Instead, we walk slower, more carefully, more humanely. The lab, in this moment, becomes more than a room of science. It becomes a place of stewardship, a chapel of wonder and restraint, a space where dreams are gently shaped by conscience. You lie quietly now, breathing the peace of knowing that questions, not just tools, shape the world. You are not just a recipient of discovery. You are a participant in its unfolding. The world you imagine matters. The stories you value become part of the future that CRISPR writes. And perhaps the most important ethic is this, that we remember each spiral of DNA belongs to a person, a being of breath, memory, and longing, not a code to be corrected, but a life to be honored. So the debates continue, not to stall, but to shape with care, to fold hope inside humility, to keep the candle lit as we step into the unknown. In the next chapter, we will follow the glowing edge of that unknown into the cells of plants and animals, where CRISPR is already sculpting new possibilities. What does it mean when we begin to redesign the living world around us? And what happens when the garden begins to answer back? The womb is quiet. A gentle tide of warmth surrounds you, and in this delicate darkness, something extraordinary stirs. A child is not yet born, but already a story is being shaped, a story once written in ink that could not be erased. Now, a soft whisper dares to edit that tale. Before the first breath, before the first cry, you imagine a mother's hands resting on her belly, hoping, dreaming, maybe praying. There's joy in that touch, but also fear, a fear passed down through generations. Hemophilia, cystic fibrosis, Tay-Sachs, muscular dystrophy, whispers in the bloodline, haunting lullabies carried in the spiral staircase of DNA. She knows. She's seen what this inheritance can do. And now, for the first time in human history, there is a choice. CRISPR arrives like a soft breeze through a half-open window, not to crash, not to overwhelm, but to gently rearrange the fragile furniture of life before the child awakens into the world. With a microscopic pair of scissors and a map of what might come, scientists step into the earliest pages of life's unfolding. Imagine this. A single-cell embryo rests on the tip of a needle, as fragile as a dew droplet balanced on a blade of grass. The entire potential of a human being rests within it. Limbs not yet formed, eyes not yet opened, but inside, the blueprint of a lifetime quietly pulses. And somewhere deep within, a typo lurks. A small mistake in the instructions, just one letter wrong. But that single error could mean a lifetime of suffering. CRISPR sees this letter, and with precision honed from years of study, it slips in like a shadowless ghost, and snips, not with violence, not with noise, but with intention, with the care of someone editing a sacred poem. And then, with the same quiet grace, it replaces that one flawed letter with the correct one. The corrected cell divides, then divides again, until there are millions, all carrying the edited message. A gentle rewrite of what could have been a sentence of pain. You drift deeper into the scene, where science meets something almost spiritual. It's not just genes that are being edited, it's futures, and maybe fates. The idea feels weightless at first, like moonlight, but it grows heavier the more you sit with it. Because in healing what's broken, you also brush close to the essence of what it means to be born, to inherit, to carry stories that are older than you. Are we removing pain, or are we rewriting identity? The embryo does not speak. It cannot consent. It cannot argue or agree. It is, for now, pure potential. And in that silence, a deep question hums. Who decides what is broken? You think of the deaf community, of those who do not see their condition as a defect, but as a culture, a language, a way of being. You think of people with dwarfism, with neurodivergent minds, with traits once feared and misunderstood, and still too often misunderstood. If we begin to edit these traits away before birth, are we offering freedom or erasure in the calm stillness of the lab? Researchers walk this edge with reverence. The scissors they hold are not gleaming swords, but fine tools, humble, cautious. They know the power they carry. They know the weight of editing life before it begins. And still they move forward because they have seen too much suffer not to try. Sometimes healing comes before the wound ever opens. Sometimes love is a decision made in the quietest moments, not with grand gestures, but with the smallest of edits, in the smallest of cells. There are clinical trials already underway. Some aim to cure sickle cell anemia in embryos. Others hope to prevent Huntington's disease, a cruel thief that robs families generation after generation. The science is still young. Its steps careful, its breath held, but the direction is clear. We are learning to mend life before it unfolds. And yet, you feel the hum of something deeper, a tension not between science and nature, but between hope and humility. Because healing before birth is not just about avoiding disease. It tempts the human mind with something more, the power to shape. If we can remove pain, can we also add strength? If we can correct flaws, can we also design brilliance? And that is where the line begins to blur. The transition from healing to enhancement is not marked by a signpost, but by a feeling, a pause, a question. Tonight, you float with that question. It doesn't demand an answer. Not now. It only asks that you notice the moment, this liminal space between possibility and principle. The embryo, now edited, continues to divide. A heart begins to form. Tiny arms, tiny legs. The first beat, the first flicker. Not yet born, but already changed. And in the hush of this creation, you feel the gentle gravity of wonder, not in what we can do, but in how we choose to do it. Because when you heal before birth, you're not just touching genes, you're touching tomorrow. You exhale slowly, imagining a world where pain no longer passes down through blood, where the line between past and future is redrawn, not with violence, but with care, where birth still feels like a beginning, not a decision made too soon. But beneath that hope, another current begins to stir, a quiet question rising from the deep. If we can rewrite life, can we also write it to be more than human? Underscore, 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 underscore. And so you drift slowly into the space where dreams of healing meet the dawning light of design. Certainly, here is the next chapter, crafted exactly to 1,000 words in the poetic, bedtime style you've requested. You sit with a quiet weight of wonder, a thought curling like smoke in a still room. What happens when we change not just the self, but the story inside the body? Some changes speak softly. They are somatic, rooted in cells that live and die with you. A patch of skin, a cluster of blood, a lung, a liver. CRISPR touches them like a whisper, an edit that begins and ends in silence. You heal the body, but the line ends there. The future walks on untouched. These are the gentle repairs of modern medicine. They do not echo forward. They do not ring in the bones of tomorrow's children. They soothe, but they do not sculpt. A child with sickle cell disease, for example, may find new life when CRISPR enters the bone marrow. Just there, just enough. A somatic change, a breath given back. It is a whisper you carry alone, but then the story turns. There are edits that do not fade with the body. They nest in the germline, in the sperm, the egg, the early embryo. Here, An edit is not a whisper. It is a bell rung into the centuries. A choice made now that echoes in the laughter, the faces, the hearts of people not yet born. The science becomes less about healing and more about shaping. The language changes from treatment to legacy. And in that shift, something stirs. You imagine a tiny embryo on the glass, floating like a promise. CRISPR moves toward it, not as a surgeon, but as an architect. A base pair swapped, a mutation erased. A child who will never know the pain that was meant to be theirs. A clean page before the first word is written. It feels like a gift, but every gift carries the weight of choice. Because the germline holds more than biology. It carries memory, lineage, the mystery of chance. A wild dance of genes, shaped not just by logic, but by time and love and luck. When you touch the germline, you do not just prevent disease. You redraw the map. And maps, once redrawn, are hard to forget. Scientists pause at this line, the edge between what heals and what defines. To change the germline is to step beyond one life and into many, to write not just for yourself, but for generations. There is no undo button in inheritance. So the debate is gentle, but deep. Some say, prevent suffering at its root. Why allow a child to carry a deadly mutation when we could quiet before birth? Others say, wait, listen. We do not yet know what threads we tug when we edit the first cell. Not all diseases are simple villains. Not all traits are clearly marked good or bad. You remember that some mutations once thought harmful, like the one that makes them immune to HIV, are now viewed with awe. Evolution hides gifts in strange clothing. CRISPR does not always know which garments to remove. Still, the temptation lingers. Imagine ending cystic fibrosis before it begins, or banishing Tay-Sachs from the lineage of a family forever. Imagine the quiet joy of knowing your child will never carry what once hurt you. But imagine also the burden of that power. Who decides what should be edited out? What if curiosity tips into control? What if the line between disease and difference grows thin? Is deafness a disability or a culture? Is short stature a challenge or a charm? If we edit too much, do we lose the beautiful variations that make us human? CRISPR sits at this crossroads, waiting. It holds no opinions. It simply offers tools. It is we who must decide what kind of music the future should sing. Somatic changes are safe harbors. Germline changes are ships set to sail into generations. And you, listener, dreamer, traveler thought, you stand on this quiet shore, watching both. Some scientists propose a pause. Let's use germline editing only when no other option remains. Let's move slowly, one careful step at a time. Let's gather not just data, but wisdom. Others believe that waiting too long may be a different kind of harm. Every year without action is another life born into pain that could have been softened. Is hesitation ethical too? No answer comes easily. And perhaps that is a sign we are asking the right questions. Not all things need quick resolution. Some ideas deserve time to breathe. So CRISPR moves forward, but gently, like someone walking across fresh snow, careful not to leave heavy prints. Somatic therapies continue to grow, curing blindness, repairing blood, soothing muscles. Germline editing remains mostly theory, mostly watched, mostly whispered. But the whispers are getting louder. You imagine a world where germline edits are made with empathy, clarity, and care, where guidelines are shaped not just by science, but by stories, by voices like yours, quiet, thoughtful, human. Because what we change in the germline is not just DNA. It is the meaning of inheritance. It is the shape of identity. And as you drift now, your breath soft and steady, you begin to wonder, if we can change what is passed down, can we also choose what to keep? Perhaps the next chapter of CRISPR is not just about cutting, but about listening to history, to values, to the silence between decisions. Because in the end, science does not only ask, can we? It gently asks, in the quiet before sleep, what do we truly wish to preserve? You are not a single thread, but a woven cloth, a mosaic of moments, of memory, of matter. Under your skin, in the hush between heartbeats, your body whispers its ancient instructions. Each cell holds a message, a fragment of you, a shimmering tile in the grand picture. But not all the tiles are the same. Some glow with clarity. Others flicker with forgotten mistakes. A few, tucked deep in shadowed corners, carry instructions written in codes from long ago. Ones you didn't choose, ones you never knew existed until something began to shift. CRISPR comes to this quiet landscape not as a hammer, but as a brush, not to erase, but to repaint. Not all at once, not everywhere, but gently, patiently. One tile, one cell, one whisper at a time. This is somatic editing, a delicate art that changes only part of the story. Somatic means of the body. And these changes live only here, in this one form you inhabit. They do not travel forward into the future. They don't pass into the soft, unwritten books of children unborn. They stay here with you like a secret between skin and spirit. Imagine, for a moment, that you are a stained glass window, and CRISPR, holding its light and its tools, changes a single pane from cloudy blue to brilliant gold. The whole window is not changed, but something shines differently. You shine differently. Light finds a new way through. In diseases caused by single faulty genes, like sickle cell anemia or certain forms of inherited blindness, CRISPR offers hope not by rewriting everything, but by editing the parts that hurt. Just a bone marrow, just a retina, just a few. It's not perfection. It's not total. But it is enough to soften pain, to restore vision, to breathe ease into a life once shaped by silent struggle. And yet, the mosaic remains. One cell is healed. The one beside it is not. Over time, they mix. They talk. They learn from each other. Your body is a chorus of trillions. And CRISPR only teaches some of them a new song. What happens when the choir is partly changed? This is mosaicism, a gentle biological patchwork. A condition not of brokenness, but of multiplicity. Some cells hold the old instructions. Some carry the new. The body becomes a blend of timelines, past and possible future, stitched together in skin. You may never feel the difference. Or you might feel it deeply, in small waves, a reduction in symptoms, a new clarity of breath, a stillness where pain once lived. But always you remain a mosaic. This kind of healing is humble. It doesn't declare victory across your entire being. It works quietly, like rainfall nourishing the thirsty roots of a single tree. The forest may remain unchanged, but that one tree stretches higher, drinks deeper. That one life flourishes in calm. And then there is another layer, a mosaic not of cells, but of time. As you age, your cells divide. New ones replace old ones. Some hold the edited gene. Some do not. Over years, the balance may shift. The golden tile may fade. The cloudy one may return. Healing, in this form, is not always permanent. It is a conversation, a gentle tug-of-war between change and memory. But what if the edits were made earlier, before all the mosaic tiles had formed, before the cells had divided into blood and bone and brain? What if the change had echoed through every cell, so the whole picture shifts together? That is the realm of germline editing, a different kind of echo, a different kind of promise. But that is not where we are now. Here, in this chapter, we stay with the mosaic, the beautiful, imperfect art of partial healing. And there is beauty here, even in its limits. For to be a mosaic is also to be resilient. If one tile cracks, the whole does not fall. If one cell slips back into the old code, others still carry the new. You are not a machine that breaks when one cog falters. You are a landscape, a forest, a galaxy of cells. CRISPR, in somatic form, understands this. It does not seek to conquer you, but to accompany you. It does not demand uniformity. It offers relief. And still, the question hums beneath it all. What does it mean to change some, but not all? To edit pain without erasing memory? To carry both the wound and the salve within the same skin? You begin to live between two songs, the old melody of your inheritance and the new refrain offered by science. Somewhere in that harmony, something true begins to emerge. Not a perfect fix, not a flawless design, but a new kind of becoming. You are not a single version of yourself. You are many. You are process, unfolding. You are response and reflection and renewal. As cells shift, so do you. As some tiles brighten, the whole pattern changes. In that slow, shimmering evolution, there is something sacred, something deeply human. For how we always live like this, half rooted in what came before, half reaching toward what might be? CRISPR is not a magic wand. It is not a cure-all. But in the world of somatic editing, it is a companion to your body's own quiet attempts to heal. It walks beside you, not to replace your story, but to offer an extra chapter. You do not need to be whole to be worthy. You do not need to be uniform to be beautiful. You are, and always have been, a mosaic. And this patchwork, holds power. Even as one part you changes, the rest bears witness. There is memory in every corner. There is strength in variation. And even the unedited cells hum in resonance with those newly tuned. This is not the end of your story. It is a turning point, a soft change in light, a new breath in the long rhythm of becoming. But what happens when the change comes not just to your body, but to every child who comes after? What happens when we choose to edit not the person, but the future? That question waits just over the horizon. It leans quietly into the night, a whisper on the edge of sleep, asking, what legacy do we shape when we edit the code of tomorrow? Let me know when you're ready for Chapter 9. Certainly, here's your requested chapter in full. You close your eyes, and the quiet settles in like falling snow. This is the space between the dream and the doing, between what might be and what is. CRISPR sits in this space too, not in the realm of fantasy anymore, but not yet the everyday cure. It's a promise still being written, in careful hands, with cautious breath. In your mind, you picture a scientist in a white coat, her fingers gloved, her gaze steady. She peers through a microscope, not into cells exactly, but into the future that lives inside them. Tiny droplets on a slide hold hope, not just for one patient, but for millions. But hope, you've come to learn, is not always smooth. It's a thread spun from both science and patience. CRISPR, with all its elegance, isn't a magic wand. It's a delicate tool, one that can correct, yes, but also one that must be wielded with a quiet reverence you'd reserve for restoring an ancient painting. Touch too much, and something precious might blur. Touch too little, and the broken pieces remain. In clinical trials, the air feels different, more still. People walk in not just with symptoms, but with stories, with lifetimes carried in their blood. They bring their bodies as both question and canvas. Can this work for me? You imagine someone waiting in a hospital chair, the fluorescent lights above humming a tired lullaby. She's reading a document, pages that list side effects and uncertain outcomes. Words like experimental, potential, risk. She signs her name anyway, not because she's certain, but because hope sometimes means choosing to walk into the unknown, holding onto the thread with both hands. Some trials succeed. There are children now who once faced certain blindness, but now they see their mother's face for the first time. There are people with blood once shaped like sickles, now softened into round, flowing life. These are the victories that glimmer gently. They're whispered into medical journals, then shouted in quiet joy at kitchen tables. But not every story sings the same tune. Some edits don't hold. Some side effects appear like shadows at dusk, unexpected, uninvited. The immune system, so loyal and fierce, sometimes doesn't understand healing and pushes back. Other times, the edit lands beside its target, nudging a different gene into silence. CRISPR is still learning the language of the body, still learning that every cell carries a slightly different dialect. You cannot rush fluency. And still, even with its imperfections, even when the brush slips, this tool has painted possibility on a wall once blank. There's a kind of healing that doesn't come all at once. It arrives in patches, in careful steps and whisper revisions. It looks like one child living longer than expected, like a trial that opens a new door for just a few, but teaches doctors what to try next. Science, you realize, is not a straight road. It bends and loops, sometimes stepping backward so it can move ahead more clearly. It's like walking a foggy forest path, where each step reveals only the next route, the next clearing, but not yet the whole journey. And yet, every trial, even the ones that end too soon, etches a new note into the song of possibility. Even Paul's stories offer guidance. They say, here's where to be careful, or here's a path not worth taking twice. There's grace in that. Not all progress must be fast to be meaningful. Not all healing must be complete to be real. You begin to sense that reality, with all its slow turns and partial answers, isn't a disappointment. It's a rhythm, a tempo that gives you time to notice, to adapt, to hope again with each careful beat. In the world of CRISPR, there's still so much being tested. Techniques evolve, delivery systems improve, ethics committees debate, patients volunteer. Data accumulates like snow on a quiet hill. Each flake, a trial, a step, a voice, and when enough of them gather, they form something solid beneath your feet. For now, the world doesn't yet have a universal cure. There's no perfect answer to every illness, no one-size-fits-all remedy. But that was never the promise. The promise was progress. The promise was trying. And that is happening in quiet rooms with microscopes, in long nights at research labs, in the still courage of people who say yes to being part of something not yet certain. You are not living in a time of miracles. You are living in the time just before, the place where the seeds are planted, but not yet in bloom, the waiting time, the wondering time. And maybe that's enough, for now, to know that someone, somewhere, is inching a little closer to healing because of a trial that worked or a mistake that taught something true. Even in the imperfect moments, there's a kind of beauty to it, like watching clouds part just enough to let a sliver of moonlight in. Maybe one day, the edits will be smooth, safe, swift. Maybe one day, doctors will correct genes, like typing a letter. But even then, the lessons from today will echo like a hum beneath that ease. Because now, as you lie here, between sleep and thought, between science and soul, you understand something deeper. That CRISPR story is not just written in data, but in people, in their risks, their waiting, their bravery. And as your breath slows, your thoughts drift to what comes next, not the tool itself, but the hands that will hold it, the minds that will shape it, the choices that will decide where it may go, and who will be allowed to follow. And when the power to edit life becomes common, who decides which stories are worth rewriting and which are not? Certainly. Here's your final chapter of the CRISPR Bedtime series. You sit quietly in the afterglow of discovery. The echoes of all that's come before still gently stir in the air around you. The stars have not shifted. The cells still breathe silently inside your body. But something feels different. The story has reached your hands. You are no longer a bystander in this vast unfolding. You are now among the dreamers who carry the quill, the watchers who whisper ideas into the winds of change. The science has never been far from you. It has always flowed through your blood, shaped your mind, and echoed in your wonder. But now, the pen is yours. CRISPR, this elegant molecular scalpel, is not simply a tool of precision. It is a reflection of the questions we dare to ask. When you imagine a future where no child suffers from preventable disease, when you dream of helping plants survive drought or species heal from extinction, you are dreaming in CRISPR's language. It is not a fantasy. It is not perfection. It is possibility wrapped in caution, hope dressed in humility. Think of it like a candle in a dark forest. It does not erase the shadows, but it gives you just enough light to take the next step. Not blindly, not arrogantly, but with care. And with every step, you help shape what the science becomes. You see, the code of life is not just written in 4 letters of DNA. It's also written in questions. Should we? Why now? For whom? And at what cost? These are the questions that slow our hands and soften our steps. They are not burdens. They are blessings. threads of thought that keep the future human. Somewhere tonight, a scientist sits in a quiet lab, adjusting a microscope under warm